Hey guys, welcome back to Learn in DSA. So today we are going to solve LeetCode problem 2081, sum of k mirror numbers. Okay, so basically in this question we are provided a k mirror. So a k mirror is a positive integer without leading zeros that reads the same both forward and backward in base 10 as well as in base k. For example, 9 is a 2 mirror number. The representation of 9 in base 10 and base 2 are 9 and 1001 respectively, which read the same both forward and backward. On the contrary, 4 is not a 2 mirror number. The representation of 4 in base 2 is 100, which does not read the same both forward and backward. Given the base k and the number n, return the sum of the n smallest k mirror numbers. So input here, like in this example, is k equals to n equals 5 and output is 25. So this is how k mirror numbers are calculated. So basically, what are k mirror numbers? A number is called a k mirror number if it is a palindrome in both base 10 and base k, according to the problem given. Okay, so our goal is to find the sum of the first n such k mirror numbers, and we will do it efficiently using a beautiful idea. So let's dive into the explanation of this example. Right, so here we are provided an input k equals 2 where n equals 5. So k, that is, we require the numbers to be palindrome in base 2 and base 10, right? K is the base and the other base is base 10. So base 2 and base 10. So if we calculate in base 2, then 1 is a base 2. In base 2 is 1 in base 10 as well. 1 in base 2 is 3 in base 10, which is a palindrome. 101 in base 2 is 5 in base 10, which is a palindrome because 10 and 01 here. And in this 1 we are getting first 1 and the end as well as 1. And 7111 is again a palindrome. 1001, so 1001, this is again a palindrome, and this 9 is also a palindrome. So the sum of all the palindromes in base 10 is 1 plus 3 plus 5 plus 7 plus 9 equals 25, right? Similarly, in the example 2, we are provided k equals 3. So basically, we require the numbers to be in base 3, and we need 7 such numbers from starting from 1, right? So in base 10, 1. So first base 3 number which is similar, so 1. 2 is also similar in base 10 and base 3, and both are palindrome, right? And in base 3, 11 is a palindrome, and 4 in base 10, 4 is also a palindrome, which is a conversion of 22 is again a palindrome, which is 8 in base 10, and 111, 111. So this is also a palindrome because of these 111 and this 111, right? So this is again palindrome in base 10, 121. So 1221, right? Equal in both sides if we divide it. 151, this is again palindrome, and 12121 is again palindrome. So by getting the sum of all those, so it is 1 plus 2 plus 4 plus 8 plus 121 plus 151 plus 212, right? So it is 499. Similar goes with the example 3, but it is a very bigger example, so we will not be explaining that. So basically, we are provided k is less than equals 9 and greater than equals 2. So a number can be decimal, and it is lesser than n, it is not equals to base 10 in any case, right? And n is less than equals 13, greater than equals 1. So basically, in this we are not taking count of any leading zeros, right? So basically, there are no leading zeros, and 0 is not taken as a case in any of this. We are starting from 1, right? So let's dive into the coding part of this, right? So what we can do to check if a number is palindrome in base 10. So for that, here we are going to write the code in C++. You can choose your desired coding language, but the logic can be same, right? So what can be the approach to solve this question? So here in the question provided, we are given k, where k is the base k, and we need to check if the number is palindrome in base k as well as in base 10. Then it is a mirror number, and we need to provide the sum of those k mirror numbers in the output, like the first 10 numbers. So how we can approach this question? We generate palindromes directly in base k, because there are fewer of them, like, right? So instead of generating numbers randomly or from base 10 and checking base k, what we can do is we generate palindromes directly in base k, because there are fewer of them, the base k numbers grow slower, and many base 10 palindromes are not base k palindromes, right? So for each base k palindrome, we convert it into a decimal, we check if it is also a palindrome in base 10, and if yes, then we add it to our list, else we not. We stop once we found n such numbers, right? So how we build palindrome in base k? So for length equals 1, palindromes are from generally from k1 to k minus 1. So we skip 0 because leading zeros are not allowed here. And for length greater than 1, we generate the first half of the digits, mirror them to form the full palindrome. And one such example could be if the half is 1 and full even is 1 1, then this can be palindrome. If the half is 1 0, then full odd one can be 1 0 1 and the even can be 1 0 0 1. If the half is 1 1 and full even can be 1 1 1 1, right? So this guarantees that all generated numbers are palindrome in base k, right? So let's move on to the coding part. So first what we need to write, we need to create a function which will be able to check if a number is palindrome in base 10. So for that, what we need to write here is we need to take a boolean to check if it is true or false. So boolean is base 10 palindrome, right? Here we are providing long num, right? And what we need to do here, we need to convert the number to a string and check if it reads the same forwards as well as backwards. That will be palindrome, right? The forward and the backward are equal, then it is palindrome. So it will be string s equals to underscore string num, right? And return s equals string s dot r begin comma s dot r end, right? So we also need a function to convert a number represented in base k digits to its base 10 equivalent, right? We are generating the base k digits and we need to convert those base 10 to base k equivalents to check if the base k is also palindrome or not. So to write that, what we can do is we need to create a function base k to decimal where we will be providing the const in digits and the k as well, because k carries the base k part, right? So for that, long base k to decimal, right? And const vector int digits. We are passing those digits and we are also passing our k, right? So what we need to do here, we need to initiate a long num equals 0 and then we'll be iterating through each of the digits, and we need to multiply the current number by base and add the next digit. So this is the logic exactly how we convert a number to its to convert from base k to base 10. This is the logic, like we need to multiply the number by k and then add the next digit, right? So for that we need to initiate a long num equals 0 and then we'll be moving on through a loop int d digits, right? These digits are passed and then this is the logic, like num equals num into k plus d, right? So this will be converting our base k to base 10, and what we'll be doing, we'll be returning the num. This num will be the base 10 number, right? So what to do next, we need to a function to generate base k palindromes and check which are also base 10 palindromes, right? So base k palindromes need to be generated first and then we will be checking if those base k palindromes are also base 10 palindromes. So to generate base k palindrome, we can create a void base generate base k palindrome function, right? generate base k palindromes, where we will be passing the k first, because to convert to base k we need a k, right? And we will be passing int n as well, because we need to calculate the first n base k, right? And we will be passing the vector result as well. Right, for that. Now what we need to do, we need to try all palindrome lengths starting from 1, right? Because 0 is not allowed, and we'll be iterating through each of them. So to iterate that, we need a for loop. For int length equals 1, the size should be lesser than n, right? The vector size should be lesser than n, right? Less than n plus length, right? So what we will be doing, we will be calculating the first half length, and then we will be replicating that first half to the second half as well to get the palindrome number. Like, we'll be replicating the first half reverse in the second half, and that will be the palindrome number, right? So for that, to create the first half, we need a int half length. Like, we are creating a integer whose length will be length plus 1 by 2. Why plus 1? Because we don't need any leading zeros. And to calculate the start, what we can do, in start equals, if length is equals 1, then what we will be doing, we will be just printing the output as 1. And if not, then we will be taking the start point for the first half, like k comma half length minus 1, right? Pow k comma half length minus 1. And what will be the end? So end will be power of k comma half length, because here we don't need the concept of length equals 1. It will be already covered in the start part, right? So for that, int end equals power k comma half length, right? So what we need to do next, we need to loop over all half numbers, right? So for to loop that, for int half equals start, and half is less than n, and result dot size is also less than n, half will be incremented. So we need to create a vector int half digit, and temp will be pointing to half, and we'll be converting the half number from base 10 to base k, right? So for that, we need to create a vector half digit, vector int half digit, right? And temp will be pointing to half. And to convert the half number from base 10 to base k, what we will be doing, we will be simply using a while loop while temp is greater than 0. So each half digit will be pushed back to by temp using temp modulo k, right? Half digit, in half digit we need to push back those values, push back temp modulo k, right, to store the last digit. And to move to the next digit, what we'll be doing, we'll be doing temp by equals k, right, to move to the next digit. And at the end, we need to reverse to get digits in correct order, right? The first half is already correct, and we need to reverse the second half. So for that, what we'll be doing, we'll be simply using the reverse function, reverse half digits dot begin comma half digits dot end. Half digit, right, not digits. Right. So to create a full base k palindrome by mirroring the half, we need to create again a vector int full digits similar to the half one, right, which will be initially the half digit, and then to determine how much of the half to mirror, like if the number is even or odd, if the size is even or odd. So like if it is 1 0, if it is 1 0 and the size is 3, so it will be 1 0 1, right? We need the size as 3. So what we'll be doing, we will not be doing like 1 0 0 1, we will be doing 1 0 1, right? So to maintain its, if it is even or odd, so for that we'll be simply we'll taking an integer I, and if the length modulo 2 is equals to 0, then we will be doing the half digits or size minus 1, and if the length modulo 2 is not equals to 0, then we will be doing half digits dot size minus 2, right? Half digits dot size minus 1, else half digits dot size minus 2, right, for the even and odd case. To append, now to append the mirrored digits to form the full palindrome, like the first palindrome will be containing some and the next palindrome will be containing some. So to append those mirrored digits to form the full palindrome, what we will be doing, we will be using a while loop while I is greater than equals 0, and we will be pushing back the digit pointing to index minus minus I minus minus in the full digits vector. Have full digits dot push underscore back. What will be pushing back? We will be pushing back the half digits pointing to the index minus minus. This I is the index, right? Now to convert the full base k palindrome to base 10, we will be using a long decimal val, which will be calling this base k to decimal, this function, right? And this will be converting this to full base k palindrome, right? So to call that base k to decimal, right? And we will be passing our full digits in this and the k as well, right? Now to check if it is also a base 10 palindrome, what we need to do, we will be calling that our function is base 10 palindrome, in which we will be passing the decimal val. So for that we need to do this, like if is base 10 palindrome, we have already created this function above, so we will be calling this like this, and what we will be doing here, we will be just pushing back the result underscore push back the decimal val here, right? Decimal val, right? So now the main function that returns the sum of the first n k mirror numbers, so which is already provided in the question, long k mirror int k comma int n. So for that what we need to do, we need to first create the vector long result, which will be storing the valid k mirror numbers, vector long result, which will be our output, which will be storing the valid k mirror numbers. Now we need to call the generate base k palindrome, which will be generating the palindromes in base k and collect those values in base 10 as well. So generate base k palindrome k comma n comma, we'll be passing the result vector as well, and we'll be using a long sum, which will be initiated with 0 to calculate this sum, because we need the sum of those n numbers in the output, right? That is our end goal. So for that we need to use a for loop to iterate through each element of the result vector, and then we will be calculating, we will be just adding up this sum, right? So for long x, let's take an x which is iterating through each of the index of result, and then it will be just calculating sum plus equals x, right? And we will be returning the sum in the output, return sum, right? So let's run this and see if it is working or not. So yeah, this is a simple error of we have used this third bracket which should be used here, right? uh, because this is going in one loop, right? This void generate base k palindrome is going in one loop, so this third bracket will go here. At line 29 here we have used half digits, a small typo. Here also we can see full digits, it is correct. No, it here also we are doing wrong, full digit, right? So let 23 full digits again. So yeah, I already told we need to create this long sum equals 0, and then that sum will be calculating this. So it will be like this. So it is accepted, and here we can submit it to check if it is working fine. So yeah, it is working fine. Now let's move on to the time complexity of. Basically this algorithm is using complexity of big O of n into log square n, which gives us a practical time complexity for this kind of question where the n is limited to 30, so it will not be that much difficult for it to work. And the space complexity here is big O of log n per number to whole digits, right? And let me show you the whole code again, because there were a lot of typo, like at a lot of places I wrote half digits instead of half digit and full digits instead of full digit. So please look into the code again, and if you find this explanation helpful, give it a like, share with your friends, and don't forget to subscribe for more detailed breakdowns of such tricky DSA problems. Well, this was a LeetCode hard level DSA problem. Thank you for watching, guys.